All right, we're ready for part 2, section 7. We're gonna jump right into example 8, which relates to example 7 at the end of the last video. This time, find a quadratic equation. Quadratic, so again, that means n equals 2, that's our degree, with roots 2 plus and minus 3i. 2 plus or minus 3i. Well, to find a quadratic equation, you need two things. All right? The sum of the roots. Well, the sum of the roots, that means to add 2 plus 3i plus 2 minus 3i. Well, that's just, the 3i's cancel. That's just 4. So the sum of our roots is 4. The sum of our roots is 4. The product of our roots, that would be 2 plus 3i times 2 minus 3i. Do some FOIL. 2 times 2 is 4. The outers and inners will cancel, folks. And you'll be left with minus 9i squared. Well, remember, I squared is negative 1. That's 4 plus 9. Answer, 13. That's the product of the roots. Well, since this is a quadratic equation, we're essentially done. All right, use your formula. It'd be x squared minus the sum of the roots. The sum of the roots was 4. Now check that. Make sure it works with your formula. Your formula said the sum of the roots is the opposite of the second term divided by the first term. Well, the opposite of negative 4 would be positive 4 divided by 1. That's positive 4. Sum of the roots. Check. It worked. Cool. Plus the product of the roots. And the product of the roots we got to be 13. Well, let's check that. The degree is even, so it would be the constant divided by the leading coefficient. Well, the constant here is 13 divided by the leading coefficient 1. Well, that's 13, which is what we got. It worked. There's your equation. Now, this shortcut, guys, only works for quadratic equations. You could have also done what I like to call brute force. That's where you just multiplied it all out. So check this out. X minus the first factor. The first factor was 2 plus 3i. I mean the first 0. The second root was 2 minus 3i. Now what you can do here is distribute these negatives. And we're going to end up with the same answer. Check it out. X minus 2 minus 3i. X minus 2 plus 3i. And now you need to do the distributive property. You need to multiply all this together. So, folks, you're going to have to distribute x to x, x to minus 2, x to plus 3i. And then you're going to have to go negative 2 to x, negative 2 to negative 2, and negative 2 to 3i. And then finally, negative 3i to x, negative 3i to negative 2, and negative 3i to 3i. All right, here we go. Use the distributor. X times x is x squared. X times minus 2 is minus 2x. X times 3i is 3ix. We're done with this guy. Cross him off. Minus 2 times x is minus 2x. Minus 2 is plus 4. Minus 2 and 3i is minus 6i. Cross him off. You're done. Now distribute the 3i. So I got minus 3ix plus 6i minus 9i squared. Which, let's go ahead and just rewrite as plus 9. Plus 9. Okay, plus 3ix and minus 3ix cancel. So, x squared has no friends. He's like Mr. Williams, no friends. Minus 2x is minus 4x. Plus 6i and minus 6i cancel. Looks like I have plus 4 plus 9. That's plus 13. Equals 0. And looky there. Same equation we got over here. Here we used the shortcut. Here we just did it brute force. We just multiplied it all out. Whatever way works for you, I would use the shortcut. That's the point. Okay, so let's get creative now. See what we can come up with. A cubic equation, cubic. Let's make a note there. Cubic. That means n is 3. It means we have 3 roots. With integral coefficients, what that means is its coefficients are integers. Has no quadratic term. No quadratic term. Let's make a note here. If there's no quadratic term, then that means this b right there, b must be 0. That's important. We're going to come back to that. It has one root of 3 plus I root 5. What are the other roots? Well, over here, let's label all of our roots. 3 roots. Root 1, I gave to you, 3 plus I root 5. Root 2, you should be able to tell me. Because remember the i's, they're lonely, they always have friends. He's 3 minus I root 5. Boom. Alright, now I need that third root. Now remember, this is a cubic polynomial. And what did we say earlier about cubic polynomials? One arrow goes up, the other arrow goes down. That means it must cross the x-axis somewhere. So this third root is some real number. X equal r. That's the third root. And it's got to be real. It's got to be real. Let me put root here, not real. Third root. But it's got to be a real root. Alright, let's use what we know here. What do we know? What do we know? Well, we know the sum of the roots is defined by the opposite of the leading coefficient, or the opposite of the second coefficient divided by the leading coefficient. Let's think here. Sum of roots. I have a formula. It's the opposite of the second coefficient divided by the leading coefficient. But wait a minute. What is the second coefficient? It's 0. In this particular problem, think about this. What's the second coefficient? In general, it's b. So this would be the opposite of b divided by the leading coefficient, which is a. Well, wait a minute. But b is just 0. So this is just 0, or the opposite of 0 if you want, divided by whatever a is. But I don't care what a is. The point is I'm going to get 0. So the sum of my roots is 0. Think about that. The sum of the roots is 0. Well, how does that help us? Well, Mr. Williams, we know 2 of the 3 roots already. If I know that all 3 of them add up to 0, can I find the third one? Well, sure. Take the first root, 3 plus I root 5. Plus, remember, because we're doing sum, the second root, 3 minus I root 5. Plus the third root. What's the third root? What's the third? Wait a minute, I don't know, but I do know it's some real number. I do know it's some r. Well, what do they have to add up to? Well, wait a minute, we said the sum of the roots is 0. That came from this formula up here. That came from the fact that b was 0, from the fact that we knew it had no quadratic term. Well, I can solve this. Okay, 3 plus 3, that's 6. I root 5 minus I root 5 just cancel, so 6 plus r is 0. Wait a minute, so r is negative 6. That's the third root. That's the real root. So my 3 roots are 3 plus or minus I root 5. Those are complex roots. And the third one, negative 6. Cha-ching. There it is. Sweet. All right, that's the power of Theorem 5. That's the power of Theorem 5. Last example. Here we go. Okay? Find a cubic equation. So n equal 3 again. I got 3 roots. With integral coefficients, that means that the coefficients are integers. That's ... numbers like negative 3, negative 2, negative 1, 0, 1, 2, 3. Integers include the negatives, okay? That's a misconception. That has roots. One of the roots is 3. So that's the real root, okay? Think about that. The other root is 7 minus I. 7 minus I. Alright, so here's our goal. It's a cubic, but a cubic is composed of a linear, and our linear factor would be what? X plus 3 or x minus 3? X minus 3. Times our quadratic. And now we don't know our quadratic, but remember we came up with a shortcut for quadratics? It's x squared minus the sum of the roots times x plus the product of the roots. The product of the roots. And all this will be equal to 0. Well, let's deal with just the quadratic. In other words, let's kind of just forget about the x minus 3 for now and only deal with this dude. Well, if 7 minus I is a root, what's that mean about the other root, the third root? Well, it's got to be 7 plus I. So I got 7 minus I, find the sum of the roots, plus 7 plus I. Well, the i's cancel. That's 14. Sweet. Find the product of the roots. Do the same thing. 7 minus I times 7 plus I. Well, that'd be 49. Minus I squared is really plus 1. Answer 50. Okay, so my quadratic, remember, it's x squared minus the sum times x plus the product. So it's x squared minus the sum is 14 plus the product, which is 50. Now that's just my quadratic. I need to put it with my cubic. So bring back that linear factor that we buried up here at the top. See? X minus 3 times my quadratic. And there you have it, friends. You have a cubic equation. Now it's factored, so you could multiply all this together if you want to. You get x cubed minus 17x squared plus 92x minus 150. All I did there was I did the distributive property. You with me? All I did was the distributive property. If you want, you can check me on that. Now that was doing the problem with theorem 5. Okay, the sum and the product method. You could have also if you wanted to, you could have done brute force. You could have done, okay, x minus 3 is one of the factors. X minus 7 minus I is one of the factors. And x minus 7 plus I is one of the factors. That does not sound appealing. And you could have multiplied that all out, and you would have gotten this blue equation right here. I highly recommend knowing the shortcuts. But you could have done that brute force. Don't recommend it. Would have worked. Well, for section 7, that's all I got. In fact, for chapter 2, that's all I got. I hope you had a blast. I know I did. I will catch you all later. I'm out.